morning children. Today let us study about the special properties of phenol. Yesterday we have studied two types of chemical properties of phenol. Today we are going to start with the special reactions of phenol. In that first one, let us consider Riemann-Tiemann reaction. Children, these reactions are very important. So in Riemann-Tiemann reaction we can say that phenol undergoes reaction with chloroform. It reacts with the chloroform at about 340 Kelvin in presence of sodium hydroxide, and you will be getting salicylic aldehyde as the product. You will be getting salicylic aldehyde as the product. Is it clear? Or we can call it as 2-hydroxybenzaldehyde will be the product. Salicylic aldehyde or salicylic aldehyde or 2-hydroxybenzaldehyde will be the product. Is it clear? Phenol reacts with the chloroform at about 340 Kelvin in presence of sodium hydroxide and produces salicylic aldehyde. Second one we can consider Phenols reaction. In this case, again phenol reacts with the carbon dioxide under the same condition, that is around sodium hydroxide, and here you will be getting salicylic acid as the product. You will get salicylic acid as the product. Here 2-hydroxybenzoic acid will be the product. Is it clear? In Phenols reaction you are getting salicylic acid. Now children, the salicylic acid are very important reagents. What? Salicylic acid, when undergoes reaction with acetic anhydride, you will be getting a compound 2-acetoxy-benzoic acid will be the product, or it is otherwise called aspirin. Is it clear children? What is the chemical name of aspirin? 2-acetoxy-benzoic acid will be the product. Salicylic acid, it can even ask for conversion process, how to convert phenol to aspirin. So phenol undergoes Phenols reaction and produces salicylic acid. Salicylic acid on reaction with acetic anhydride will give you 2-acetoxy-benzoic acid, or it is otherwise called aspirin. At the same time, the salicylic acid undergoes reaction with phenol. It further reacts with the phenol and you will be getting phenyl salicylate as the product. Okay, you will be getting phenyl salicylate as the product, and this has this trade name Salol, which is an intestinal antiseptic. Salicylic acid undergoes reaction with phenol and produces phenyl salicylate, which is termed as Salol, and it is an intestinal antiseptic. At the same time, the salicylic acid further reacts with the methanol and you will be getting methyl salicylate as the product. You will be getting methyl salicylate as the product. This is one of the main ingredient in the perfume, that is oil of wintergreen, as well as in iodex, and in mouthwash also you can see the presence of methyl salicylate. Is it clear children? That is why I told you the salicylic acid is very important organic reagent. Okay, now let us consider the next reaction, that is phenol undergoes oxidation also. Phenol undergoes oxidation. Third one, let us consider oxidation. If phenol undergoes simple oxidation in presence of air, that is, if it undergoes oxidation in presence of air, you will be getting benzoquinone as the product. Phenol undergoes oxidation in presence of air and produces benzoquinone as the product. On the other hand, if it undergoes oxidation in presence of potassium persulfate, that is K2S2O8, you will get a mixture of 1,2-dihydroxybenzene. We have 1,4 plus 1,4-dihydroxybenzene. When phenol undergoes oxidation in presence of potassium persulfate, you will get a mixture of 1,2-dihydroxybenzene and 1,4-dihydroxybenzene, and this reaction is termed as Else persulfate reaction. Is it clear? Oxidation of phenol in presence of potassium persulfate will give you a mixture of 1,2-dihydroxybenzene and 1,4-dihydroxybenzene, and this reaction is termed as Else persulfate reaction. Is it clear children? Next one, let us consider coupling reaction. That is, in first chapter we have studied how to prepare benzene diammonium chloride. So here we can see that undergoes reaction with benzene diammonium chloride. It undergoes reaction with the benzene diammonium chloride, and just you remove a molecule of HCl and you will be getting para-hydroxyazobenzene. You will get para-hydroxyazobenzene. This is a organic dye. Is it clear? Phenol reacts with the benzene diammonium chloride and produces para-hydroxyazobenzene. Is it clear? Next one, let us consider reaction with phthalic anhydride. That is, in this case, two molecules of phenol. That is, if you just consider two molecules of phenol undergoes reaction with phthalic anhydride. It reacts with phthalic anhydride and just eliminate a molecule of water, and the resulting product is used as an indicator, which is called phenolphthalein. You are getting phenolphthalein as the product. Is it clear? Phenol reacts with phthalic anhydride and produces phenolphthalein as the product. This is phenolphthalein. Okay. Two molecules of phenol undergoes condensation with phthalic anhydride and produces phenolphthalein as the product. Next, and the last property of phenol, let us consider Lieberman's nitroso reaction. In this case, children, that is in Lieberman's nitroso reaction, phenol is treated with the sodium nitrite, which is dissolved in concentrated sulfuric acid. You will get a red color solution. Phenol is treated with the sodium nitrite, NaNO2, which is dissolved in concentrated sulfuric acid, and you will get a red color solution. NaNO2 plus S2SO4, you will get a red color solution which changes to blue when it is treated with alkali. Is it clear, children? When phenol undergoes reaction with sodium nitrite, which is dissolved in sulfuric acid, you will get a red color solution, and this red color solution turns to blue on reaction with sodium hydroxide, and this is termed as Lieberman's nitroso reaction. Okay, children, that is about the properties of phenol. In the next class, we will study about ethers. Thank you.